Today's video will be about computer memory, types of computer memory and properties, plus numerous interesting facts about computer memory. I hope that the information provided here will be useful to someone. Computer memory is a kind of working space of the PC. Every time we run an application or open a file, data and files read from the hard disk are copied into RAM, abbreviation random access memory. Memories in terms of operation can be divided into dynamic RAM and static ROM, abbreviation read-only memory. Most computers use dynamic memory, which must be continually electrically refreshed to store data. Its opposite is static memory, which does not need refreshing. Another of the divisions is the distinction based on storability. A large amount of RAM in a computer means that many programs can be run simultaneously and that the computer is very stable and fast, as the additional memory means that Windows makes less or no use of virtual memory. All versions of Windows use the so-called swap file, which saves the contents of the memory on the hard disk in case it becomes insufficient. The swap file is a kind of buffer to which data is written in order to be able to retrieve it at the right moment. From the system point of view, it is additional memory. Unfortunately, reading and writing data to the hard disk is much slower than the same operations performed directly in RAM. Frequent references to the hard disk slow down the computer. This is the reason for the unreasonable random activity of the hard disk, which checks for free space and adjusts the size of the swap file. So the more RAM you have installed in your computer, the more stable your computer works. Depending on the type of computer, its intended use, the operating system and the applications used, we can determine how much RAM we need for normal computer operation. In the case of the DOS operating system, a minimum of 1 MB of memory was sufficient, and for games under DOS 4 MB. When the DOS overlay, Windows 3.x, entered the market, the starting level was 8 MB. Windows 95 already required a minimum of 8 MB, and stable operation was only possible with 16 MB, while 64 MB was not too much when using powerful graphic applications. The next Windows 98, May 2000 stable work with 64 MB, but even this is insufficient for some applications written for these systems. For today's computers, 128 MB of RAM is the minimum to ensure comfortable work. All modern computers are additionally equipped with a cache memory. This additional memory is installed in the computer because the speed of processors has increased to such an extent that regular RAM has become too slow for the processors. Super-fast caches improve processor performance by reading data in advance and trying to predict what data the processor will pull from RAM. In a computer we still have what is called Cmos Memory. This is a volatile memory that stores the BIOS configuration settings. To ensure that the data stored in it is not lost when the power is turned off, a battery on the motherboard provides continuous power supply. Thanks to the battery, the computer always knows the current date and time. RAM. A basic type of random access memory, indispensable in every computer, storing all or part of the currently executed program. RAM is volatile, which means that when the computer is switched off, the information it contains is lost. This memory is often called DRAM, dynamic RAM, because of its operating principle. Each memory cell contains a capacitor, capacitance, which, when charged to a certain voltage, stores 1 bit of data. The capacitor quickly discharges and the contents of the cell must be systematically refreshed by addressing it and recharging the capacitor. This process is called refreshing the memory and must be done cyclically. Operating memory is in constant contact with the processor, for which it logically represents an ordered sequence of cells addressed from 0 to 2n, where n is the number of bits of the processor address register. Operating memory may be implemented as permanent memory or writable memory. The size, capacity, of the working memory, apart from the speed of the processor, characterizes the capabilities of the computer. Modern PCs usually have tens of megabytes of working memory. Such amounts of memory are required by programs using graphical interfaces. RAM is divided according to structure. SRAM, static RAM, static memory. It is characterized by a very short access time to a particular cell and non-volatility. Unfortunately, SRAMs are expensive, so they are mainly used as cache memory. DRAM, Dynamic RAM, Dynamic Memory. This memory is slower than SRAM and in addition it is volatile. In order for this memory not to lose data, it must be refreshed with a frequency of at least several hundred Hz. The refreshment consists in simple reading of the cell contents. SDRAM, Synchronous Dynamic RAM, Dynamic, Synchronous Memory. This memory is similar to DRAM, except that access to memory cells is synchronized with the external clock timing the processor. Division according to the access. FPM RAM, Fast Page Mode RAM. This memory is organized in pages, with the fastest access to subsequent cells within a page. EDO RAM, Extended Data Output RAM. This is the memory where the address of the next cell can be read out while the cell is being read. BEDO RAM, Burst EDO RAM. In this case instead of one address, 4 addresses are downloaded, however only the first address is issued to the bus, which significantly increases the access speed. ROM. ROMs are used in practice for storing basic configuration functions and operating the computer's operating system. They are generally used to store information about port types, RAM used, disks, etc. ROM memory called EPROM. Read-only memory. The content of this memory is maintained after powering down. ROM is most commonly used in computers to store the mainboard BIOS, but also other devices have their data stored in this memory, for example boot procedures. It stores basic diagnostic tests of the microcomputer. ROMs are mainly designed to hold the boot sequence of instructions, complete driver and microprocessor device operating programs, as well as fixed and rarely changed fixed data. Due to the way of data insertion, ROMs can be divided into ROM programmed with a mask ROM. Its content is determined on the basis of a pattern provided by the user during the technological process. This memory is designed only for reading, which in many cases makes it impossible to use it. PROM, Programmable Rom Memory. It is supplied by the manufacturer in an unprogrammed state with the possibility to determine any of its contents once directly by the user. The correct memory content is set once by electric burning of appropriate internal connections. Any mistake during programming eliminates the programmed circuit. EPROM, Erasable Programmable ROM. The most popular type of erasable and programmable memory with non-volatile information content. Erasing of the content is performed by intensive irradiation with ultraviolet ray. It is not possible to erase individual memory bytes, but the process of reprogramming the memory contents can be repeated several times. The expected lifetime of data stored in EPROM memories is at least 10 years. EPROM memories, Electrically Erasable Programmable ROM. Each byte can be electrically erased and the new contents written directly to the device in which the memory normally operates, and one write cycle is sufficient to program any byte. Taking advantage of this capability makes this memory ideal for running new software or modifying the contents of existing memory. It is assumed that EPROM memory should withstand 100,000 reprogramming. To the PC, EPROM came immediately, as soon as their price began to allow it. The possibility of extending the moral life of the motherboard by replacing the BIOS was very attractive to computer manufacturers. Especially that the availability of such memory coincided with the beginning of PC standard diversification, the processors used in them ceased to be faithful copies of Intel. Flash EPROM memory. In this type of memory usually single bytes can't be erased or programmed. It is possible to erase and program by blocks of memory or as a whole. Flash memories can withstand from 100 to 10,000 erasing and programming cycles. Cache memory. Due to the very high speed of modern processors, a fast cache memory is used in PCs for frequently used data, forming a buffer between the slow dynamic operating memory and the fast processor. All currently manufactured processors, Pentium, are equipped with an internal cache memory with a capacity of a few or several kilobytes. This memory is marked with the symbol L1. In addition, so-called external cache memory, called LP2, is placed on boards. For this purpose, very fast static RAM memories of small capacity, 256K1M, and short access time of several nanoseconds are used. Special integrated controllers are now being manufactured that control the operation of the cache memory. The operation of the cache controller will be explained using the example of reading data by the processor from the operational memory. A request to read data by the processor is intercepted by the controller, which checks whether the data that the processor wants to read are in the cache. In the case of a cache hit, the controller sends this data to the processor, without having to read it from free memory and thus without having to enter non-readiness cycles. In the case of a miss, the controller reads the data from RAM, sends it to the processor, and writes it to the cache at the same time. The number of hits to the total number of reads is greater than 90%, which means that more than 90% of the reads are made from the cache, and only 10% from the significantly slower main memory. This significantly increases the speed of computer operation. Did you know that? In modern computers, the ROM in its classical form, i.e. the one whose content cannot be changed, is hardly used. It has been replaced by variants, which keep their content after the computer is switched off, but can be reprogrammed in case of a special need. These include EPROM memory. This type of memory can be erased by exposing it to strong ultraviolet light, which is why it has a quartz window. The number of possible erasing and writing cycles is limited. EPROM memory, permanent memory with electrical write and erase capability. The number of erase and programming cycles is limited from approximately 10,000 to 100,000 times. Flash memory, sometimes called flash memory, a type of EPROM, faster to write. Nowadays, it is increasingly used due to its low manufacturing cost and ease of programming. As in the case of EPROM memory, no specialized equipment is needed to reprogram it, just appropriate software. Like EPROM, the number of erase and write cycles is limited. Types of computer memory. DIP, Dual Inline Package, 1981, sometimes called DIL, Dual Inline, in electronics, a type of housing for electronic components, mainly integrated circuits with small and medium scale of integration, and also elements such as optocouplers, optotripters. Leads of the element are placed in an equal line on two longer sides of rectangular enclosure. DIP housings are produced in DIP4, 4 leads, DIP6, 6 leads, DIP8, 8 leads, DIP14, 14 leads, DIP16, DIP20 and bigger. There are also produced SOIP, SK DIP and other enclosures, which differ from DIP enclosures by dimensions, distance between leads, etc. SIP, Single Inline Pin Package, is the second generation of DRAM, which was created as a result of market demand for a type of RAM that was easy to mount on the motherboard. The SIP chip used 30 pins along the edge and eliminated the need for each DRAM chip to be individually mounted. The SIP revolutionized the way personal computers, PCs, used RAM because it was much quicker to change to another model. SIM, Single Inline Memory Module, 1994/1996, is a single linear memory module. It is the next generation of DRAMs after SIP. An important innovation of the SIM chip was that it did not have protruding elements, so-called pins, as in the previous DRAM version, which was SIP, because they were placed on the surface of the mounting plate. Another important change was also that the SIM memory board was physically shaped in such a way that it could not be installed incorrectly. Technically, this helped eliminate the possibility of potential damage when mounting the memory chip on the motherboard. RAM, Rambus Inline Memory Module, one of the types of computer. Rambus DRAM, RDRAM, memory chips are placed on a computer. Memory chips, RDRAM. 16-bit RIMs on motherboards must be installed in pairs, 32-bit RIMs can be installed individually. Each unused memory slot on a motherboard must be closed with a special cap. RAM memory chips are equipped with a heatsink, which is necessary to dissipate excess heat. SDR/SDRAM, Single Data Rate Synchronous Dynamic Random Access Memory, is a dynamic memory, formerly called simply SDRAM. After the introduction of Ddr/SDRAM technology, the prefix SDR was added, synchronous, built on capacitors and transistors. Synchronous, because it operates in accordance with the processor clock, cooperation with the system bus. There are 168 pins in the SDR/SDRAM. SDR/SDRAM is clocked at 66, 100, and 133 MHz. Modules of 16, 32, 64, 128, 256 and 512 MB were produced. Production was discontinued due to the emergence of DDR, faster and more efficient memory, the size of which reaches up to 4 GB. Ddr/SDRAM, Double Data Rate Synchronous Dynamic Random Access Memory. A type of RAM used in computers as operational memory and as graphics card memory. These memories are built in TSOP and BGA housings and can withstand temperatures up to 70 degrees Celsius. Dice designed for motherboards containing Ddr/SDRAM modules have 184 contact pins and one compartment. It is a modification of the previously used SDRAM, Synchronous Dynamic RAM. In Ddr/SDRAM, data is transferred during both the rising and falling. The data is transferred on both the rising and falling edges of the clock, resulting in twice the bandwidth. The dice are powered by 2.5 V, which, together with a reduction in internal memory capacitance, results in a significant reduction in power consumption. Time of access to data located. Access time to data in RAM in the latest Ddr/SDRAM is approximately 4 ns. Ddr2 SDRAM, Double Data Rate 2 Synchronous Dynamic Random Access Memory, the next SDRAM standard after DDR, used in computers as operating memory. Used in computers as operational memory. Ddr2 memory is characterized by a higher effective clock frequency, 533, 667, 800, 1066 MHz, and lower power consumption. Like DDR, Ddr2 memory uses the rising. This should not be confused with dual-channel technology. Ddr2 memories are built in FPGA, fine-pitch ball grid array, housings. They can operate at temperatures up to 70 degrees Celsius. Ddr2 memory modules are not compatible with DDR modules. Ddr2 is currently supported by both Intel and AMD processors. Ddr3 SDRAM, Double Data Rate Synchronous Dynamic Random Access Memory, Vir3, a new standard for SDRAM type RAM, which is an extension of DDR and Ddr2 memories used in computers as operational memory. Ddr3 memory is made in 90 nm technology, which allows the use of lower voltage, 1.5 V compared to 1.8 V for Ddr2 and 2.5 V for DDR. As a result, Ddr3 memory has a reduced power consumption of approximately 40% compared to Ddr2 memory and higher bandwidth compared to Ddr2 and DDR. Ddr3 memories are not backwards compatible, i.e. they do not work with chipsets that support DDR and DDR2. Ddr3 memory support by processors was introduced in 2007 in motherboard chipsets designed for Intel processors and in 2009 in AMD processors. In AMD processors, Ddr4 SDRAM, Double Data Rate Synchronous Dynamic Random Access Memory, Vir4, a new standard of DDR SDRAM type memory. It is a development of DDR, Ddr2 and Ddr3 memory for computer applications. The weakest chips will have a clock of 2133 MHz. The fastest memories will work at a frequency of up to 4266 MHz. Ddr4 will run at 1.2 or 1.1 V, down to 1.05 V is planned. It is speculated that Ddr4 chips will be made in 32 or 36 nm size. However, this is only speculation as the Ddr4 standard has not been approved. It is known, however, that with the entry of this standard, the current model of RAM, which allows the use of multi-channel, will be broken. I hope that what has been said here has been of interest to you. I wish you all a good day. My warmest greetings to you.